we have integral of square roots. So first I will change this to power form. We have integral of e to power x plus 1 to power of 1/2 with respect to x. Next, I will do substitution. I will substitute e to power x plus 1 by t square. So we will have to find derivative of both sides of our equation with respect to x. So we have e to power x is equal to t dt to dx. Now we multiply both sides by dx. So we have e to power x dx is equal to t dt. Because we have only dx here, so I will divide both sides by e to power x. So e to power x we can reduce, and we have that dx is equal to t and dt. Ex we will find from this equation is equal t square minus 1. So we have over t square minus 1. Now we can substitute. So our integral is equal e to power x plus 1 is t square to power 1/2 dx is equal to t dt over t square minus 1. So now 2 and 2 we can reduce. I will put 2 before integral symbol, and we have t square over t square minus 1 dt. Now I can rewrite our numerator. 2 we will copy. T square, because we have in denominator t square minus 1, and we have the same power t square and t square, so we can do long division, or you can rewrite this to t square minus 1 plus 1 over t square minus 1 dt. So this is equal to, we have to copy, and we have integral of t square minus 1 over t square minus 1 plus 1 over t square minus 1 with respect to t. So this is equal. We have integral of sum, so this is equal sum of integrals. T square minus 1 we can reduce, and we have that this is equal to times integral of 1 with respect to t plus integral of 1, and denominator we can rewrite that this is t minus 1 times t plus 1 dt. So this is equal. We have 2, and in brackets integral of 1 with respect to t is t, and we have plus. Now we can rewrite our integral, our integrand. We have rational fraction 1 over t minus 1 times t plus 1. So we will write that this is identically equal to a over t plus minus 1 plus b over t plus 1. Now we will multiply both sides by t minus 1 times t plus 1 to reduce this fraction, and we will have 1 is identically equal to a times t plus 1 plus b times t minus 1. Now we'll use substitution method to find a and b. So first I will put that t is equal 1. So on the left side we have constant 1. This is equal a will be 1 plus 1 is 2. 1 minus 1 is 0, so the second expression will reduce. So we have a is equal 1 over half. And when we put that t is equal negative 1, we will have 1 is equal, first expression will reduce, and we will have negative 2b. So b is equal negative 1/2. Now we can rewrite our integral to sum of these two partial fractions. A is equal 1/2 over t minus 1, and we have plus b is negative 1/2 over t plus 1 with respect to t. We have integral, so this is equal. We have to copy 2, and we have t plus constant we will take before integral, so we will have 1/2 and integral of 1 over t minus 1 dt. Positive and negative give me negative. Will be 1/2 integral of 1 over t plus 1 dt. So this is equal to, and we have in brackets t plus 1/2. In numerator we have derivative of denominator, so integral will be equal natural logarithm of absolute value of t minus 1 minus 1/2, the same situation we have here, natural logarithm of absolute value of t plus 1 plus constant c we can write at the end. So this is equal. We can multiply by 2, and we can substitute t by, because t squared is equal e to power x plus 1, so we can write that t is equal square root of e to power x plus 1. So we will have 2 square root of e to power x plus 1 plus, when we multiply by 2, so this fraction will reduce, and we will have natural logarithm of absolute value of square root of e to power x plus 1 minus 1, and we will have minus 1/2 will reduce because we multiply by 2, so it will be natural logarithm of absolute value of square root of e to power x plus 1 plus 1. So this is equal, because we have here difference of logarithm and we have the same base, so we can rewrite that this is equal. First expression we have to copy e to power x plus 1 plus will be natural logarithm of absolute value of square root of e to power x plus 1 minus 1 over square root of e to power x plus 1 plus 1 plus constant c. I forgot to add here. So this is my solution.